Looking at factoring a polynomial that looks like this, meaning it is a trinomial, 3 terms. The highest degree you see is 2, or your exponent is 2, and the coefficient, the number out in front of the x squared, is 1, which means you actually won't even see a number out there. That's what we'll focus on today. What happens then? I think you'll like it, because really it comes back to doing a diamond problem to actually solve this. So when you have your polynomial that matches this exact situation, 3 terms, leading coefficient 1, highest degree 2, we'll make a diamond, and we'll put whatever the c value is on top of our diamond. So we're going to look for numbers that multiply to this constant, and whatever the coefficient of x is going to be the bottom number in our diamond problem. Or we're going to look for numbers that add to whatever that coefficient of x is. So here we have 3 examples. We're gonna, to do this, we are hoping to factor it, which means that it will look like something times something. Now, those somethings will be polynomials or binomials in this case usually. So we're going to draw the parentheses, and x's will be at the front of these. We'll then make a diamond, and we'll fill, in this case, our constant is 15. So we're going to put a 15 on top and an 8 on the bottom. So we're looking for numbers that multiply to 15 and add to 8. And then also think about what the signs of these answers are going to be. So we have a positive 15. So that either means both the left and the right number will both be positive, or to multiply to 15, both numbers could be negative. Well, we're trying to add to a positive 8. So we need 2 positive numbers. So 3 and 5 are the magic combination. Positive 3 and positive 5. Once we found that magic combination, we plug that in after the x's. X plus 3 times x plus 5. And by the way, we could switch the 3 and the 5 around. We could have put the 3 here and the 5 there. And this will work, folks. This is the correct factored form. If we think about it, this will get us x squared, which matches that term. When we multiply our constants together, that gets us 15. And then 5x plus 3x is 8x. Hey, our 4 multiplications or multiplication rainbows that we make here will actually get us x squared plus 8x plus 15. Cool beans. Let's try that again. So we can, assuming we can actually factor this, which we can. This is standard form. We want to factor it. So we'll write our factored form and put x's in front today. And then we'll make our diamond problem to figure out what goes after the x's. So numbers that multiply to our constant, numbers that multiply to 12, and add to negative 8. Now, think about what the signs of these numbers are going to be. My left and right numbers that multiply to 12 and add to negative 8. So we're multiplying to a positive 12. That means both numbers are positive, or wait a minute, 2 negatives multiply to a positive. So when you look at the multiples of 12 on your factor chart, ways to multiply to 12 look like this: 1, 12, 2, 6, 3, 4. None of those combinations actually add to negative 8, but we can take that group of factor pairs and make them both become negative, in which case this pair right here multiplies to positive 12 but adds to negative 8. So negative 2 and negative 6 actually solve that diamond, and then they go in after the x's. Now when you have a negative number, write minus that number. So x minus 2, x minus 6. And we can check this real quick, folks. Again, x times x is x squared. That takes care of this term. What about the positive 12 at the end? Negative 6 times negative 2, or vice versa, gets you positive 12. And then if we do our inside and outside multiples there, you get negative 2x and negative 6x. That adds or combines to negative 8x. Hey, that's totally right. That works. That's the answer. Last but not least, now we're looking for numbers that multiply to negative 12. Oof, let me try this again. Negative 12 and add to positive, wait a minute here, what number is right there? Oh yeah, it's a positive 1. So up above we had our factors of 12. Let me erase the negative marks. Oop. Uh-oh. Probably should have just redone this. Yep, Mr. P, you should have. And that's okay because actually here, these are the numbers that multiply to positive 12, but to multiply to negative 12, when you have your 1, 12, 2, 6, and 3, 4, we can either make the first numbers negative, or we can make the second numbers negative. Yeah, all 6 of these partners multiply to negative 12. But when we talk about adding the numbers then to try to add to positive 1, this adds to a positive 3 and a negative 4 adds to a negative 1. So this combination right here does not work. But this is the only combination of integers that multiplies to negative 12 and adds to 1. So that's the right pair. You know, on this one, I forgot to make my factors or my parentheses. That's okay. We can just do it all at once. So x is in front and then minus 3. In the second one, x is in front, minus 4 there. And I think you'll, oh, Mr. P, that was a positive 4. X plus 4. You know how I know that? I started mentally checking it, and I realized that I was in trouble because when I take negative 3 times positive 4, a positive 4, then I get a negative 12. So that needs to be positive. And then when I add these together to try to get that 1x, yeah, if it's a positive 4, that's 4x. And then plus negative 3x is 1x. So that is correct.